Hello my dear friends, how are you all? I hope you all are fine. So you are very welcome in our lecture number 2 of Circles. Okay, so I hope you will enjoy this lecture. So this lecture is going to be very amazing because in this lecture we are going to see a lot of theorems. Okay, yeah, so now let's see here. So today we are going to discuss here is angles subtended by a chord at a point. Okay, angle subtended by a chord at a point. Okay, so now, so my dear friends, the angle made by the line segment. Okay, the angle made by the line segment from the chord's endpoint to the center or at any point to the center or at any point on the circle, then the angle formed is called the angle subtended by the chord at a point. Okay, I hope you understand these things. Now let's suppose we have a circle like this. Okay, so here we have, you can see AB is the chord, CD is the chord, and FE is the chord. So these line segment are what? These line segment are the chords. Okay, so the end points of this chord is A and B. Okay, the end point of this chord C and D. Similarly, this F, E and E are the end points of the chord FE. Okay, so with the help of these endpoints, with the help of these chords, the angle is making at the center. The angle is formed at the center like this. Okay, similarly this angle, similarly this angle. Okay, so the angle made by the line segment from the chord's endpoint, from the chord's endpoint at the center or at any point on the circle. Like here is, you can see this is PR and this is QR. So these two line segment are the chord. Okay, and from the end points of these line segment, these chords, the angle is formed on the circle. Okay, so this is this angle. Okay, I hope you understand these things. So now let's see the theorem based on this. So here is theorem 10.1 is equal chords of a circle subtend equal angle at the center. It means it is saying that, let's suppose we have a two chords AB and DC. We have a two chords AB and DC. Okay, so if these chords are equal, let's suppose AB is equals to DC. So my dear friends, here is with the help of these chords, angle is formed at the center, which is this angle. So this angle is also equal. This angle is also equal. Okay, so we have to prove this condition. Okay, yes, so now here is, so first of all we have to write the given part. Okay, yes, so now my dear friends, we have a circle with center O, okay, and AB and CD are equal chords. Are what? They are equal chords. Okay, equal chords of circle, that is, we can write as AB is equals to CD. AB is what? AB is equals to CD. Okay, and we have to prove here is angle AOB, means this angle is equals to angle DOC, means this angle. We have to prove that these two angles are equal. Okay, yes, so now let's start. So here is, we are going to start the proof of this theorem. So now my dear friends, in triangle AOB and triangle DOC, here is, means we are taking triangle 1 and triangle 2. Okay, we know that AO is equals to OD. AO is equals to OD because these two sides are what? They are radius, and we know that radius are equal. Okay, and here is AB is equals to CD, means this AB is equals to CD because this is what? This is given. We can write this is given. Okay, and the third condition is same again. OB is equals to OC because this is also radius. So OB is equals to OC. This is radius. So we can say that triangle AOP is congruent to triangle DOC. Okay, so these two triangles are congruent by what? By side rule, by triple S rule. Okay, I hope you understand these things. So my dear friends, we can say that this angle is equals to this angle by CPCT because corresponding parts of congruent triangle. Okay, so we can say angle AOB is equals to angle DOC. Okay, so these two angles are equal by CPCT. By what? By CPCT. Okay, so this is the proof of this theorem. Okay, now let's see the theorem number 10.2. Here is this theorem states that if the angles subtended by the chords of a circle at the center are equal. Okay, now in this question here is this angle are equal and these angles are what? These angles are formed by the chords of a circle. Okay, then the chords are equal. Then we have to prove that AB is equals to DC. So basically we can say that this is the converse of this theorem of the previous theorem. This is the converse of the previous theorem. Okay, so here is first of all we have to write the given part. So again we can write it as, okay, so here is we have a circle with center O. Okay, we have a circle with center O. Okay, and here is, okay, and AB and CD are chords. Are what? These are the chords that subtend equal angle. That subtend equal angle means that form equal angles at the center. At the center. Okay, that is, here is angle AOB is equals to angle DOC. So this is what? This is the given part. Okay, my dear friends, I hope you understand these things. So now here is we have to prove is AB is equals to CD. We have to prove that these two lines are equal. Okay, yes, so now let's prove this theorem. So here is the proof of this theorem. Okay, my dear friends, so now first of all, in triangle AOB, okay, and triangle DOC, okay, means in triangle 1 and triangle 2. Okay, now you can see here is OA is equals to OD because these are what? These are the radius. Okay, and angle AOB is equals to angle DOC, means angle AOB in this angle is equals to DOC in this angle. Okay, and the reason is what? This is given. We can write that this is given, and OB is equals to OC. This is what? This is radius. So here we can say that these two triangles are congruent. So triangle AOB is congruent to triangle DOC by what? By side angle side rule. By side angle side rule. Here you can see that one side included angle and the other side. One side included angle and the other side. Then we can say that here is AB is equals to CD by what? By CPCT. So we can say that hence proof. We can say hence proof. I hope my dear friend you understand these things. So this is the proof of theorem 10.2, and basically we can say that this theorem is the converse of the previous theorem. This theorem is the converse of the previous theorem. Okay? Yes. So now the next is perpendicular from the center to a chord. Perpendicular from the center to a chord. So here is, my dear friend, let's see the theorem. Okay. So in this theorem, the perpendicular from the center of a circle to a chord bisect the chord. It means it is saying that here is, let's suppose we have a circle like this and we have AB. Okay, if we draw from the center, if we draw a line which is perpendicular to the chord from the center, then this line, let's suppose this is OX, this line bisect the line segment AB, means bisect the chord. Okay, so this is the theorem, and we have to prove that AX is equals to X. It means we have to prove that this line bisect the chord. Okay, yes. So now let's prove this theorem. Yes, so again, first of all, we have to write the given part. So we have given is, we have a circle. Okay, we have a circle. Okay, so let's suppose C is a circle. Okay, so C is a circle with center at point O. Okay, and here is AB is a chord. AB is a chord such that OX is perpendicular to AB. OX is perpendicular to AB. Okay, and we have to prove that OX bisect chord AB. That is AX is equals to BX. AX is equals to BX means we have to prove this is equals to this. Okay. Yes. So now let's start the proof of this theorem. So here is proof of this theorem. Okay. Now in triangle OAX and triangle OBX. Okay, means we are taking this triangle. Okay, and this triangle. Okay, means triangle 1 and triangle 2. So here is, my dear friends, angle OXA is equals to angle OXB, and both the angles are 90 degree. Both the angles are 90 degree. Okay, so this is what this is given. This condition is given, and OA is equals to OB because they are radius, and we know that radius are equal. Okay, and OX is equals to OX. This is common. This is common. So we can say that triangle OAX is congruent to triangle OBX. Okay, so these triangles are congruent by what? By RHS rule. You can see that here is right angle, hypotenuse, and one side. Right angle, hypotenuse, and one side. Okay, so we can say that these two triangles are congruent by RHS rule. Hence, we can say AX is equals to BX. By what? By CPCT. So this is very easy. Okay, so this is the proof of this theorem. Yes, so now let's see the another theorem. So here is the line drawn through the center of a circle to bisect a chord is perpendicular to a chord. Here is we have given it AX is equals to XB, and we have to prove that OX, this OX is perpendicular to AB. Okay, means in this theorem it is given that OX is bisect the AB, but we have to prove OX is perpendicular to AB. Okay, so now let's start to prove this theorem. So here is, first of all, we have to write the given part. Okay, so our main object is we have to write the given part. So here we have a circle with center O. Okay, with center O. Okay, and we have AB, which is a chord. AB is chord of circle. Okay, AB is what? AB is the chord of the circle, and OX bisect AB. It means AX is equals to BX. AX is equals to BX. Okay, and we have to prove okay, OX is perpendicular to AB. Okay, got it? Now let's start. So here is we are going to start the proof of this theorem. So here is, first of all, in triangle AOX and triangle BOX. Okay, in these two triangles, here is, you can see OA is equals to OB, means this line is equals to this line because we know that they are radius. Okay, and OX is equals to OX because this is what? This is common. AX is equals to XB. Okay, so this is given. So we can say that triangle AOX is congruent to triangle BOX by what? By triple S rule, side rule. So we can say angle OXA is equals to angle OXB. Angle means this angle is equals to this angle by what? By CPCT. By what? By CPCT. Okay, yes. So now here is, we know that these two angles are what? These two angles are linear pairs. So we can write here as, so here is in line AB. Okay, angle AXO and angle BXO, means we are talking about these two angles, form linear pair. So angle AXO plus angle BXO is equals to 180 degree. Is equals to what? 180 degree. And we know that these two angles are equal, so we can write here as, angle AXO plus angle AXO. We can write angle AXO in the place of angle BXO. Okay, so this is equals to 180 degree. Now my dear friends, this will become twice of angle AXO is equals to 180 degree. So angle AXO is equals to 180 divided by 2. So this is equals to 90 degree. Now angle AXO is equals to angle BXO. So both the angles are what? 90 degree. Both the angles are 90 degree. So we can say that OX is perpendicular to AB. So OX is perpendicular to AB. Okay, we can write hence proof. I hope my dear friend you understand these things. So these are the proof of this theorem. So here is, now let's solve some problems. Okay, yeah, so question number 1 is, AB is a chord of a circle with center O. Okay, with center O and radius 17 centimeter. Radius is what? we have radius is 17 centimeter. If OM is perpendicular to AB, so we have OM is perpendicular to AB. Okay, and we have OM is 8 centimeter. Okay, then find the length of chord AB. Then find the length of chord AB. Okay, I hope you get this point. So now let's start. So my dear friend, basically we have to find this length AB. Okay, so here is, now you can see in triangle AOM, we know that this is what, this is perpendicular, means this is 90 degree. So here is, we can write it as, in triangle AOM, we know that OM is perpendicular to AB. OM is what? OM is perpendicular to AB. And angle AMO is equals to 90 degree. Okay, so angle AMO is equals to 90 degree. Okay, so we can say that this triangle AMO is what? This is right angle triangle. Okay, so with the help of Pythagoras theorem, we can easily find the value of AM. We can easily find AM. Okay, yeah, so we can write here as OA square is equals to OM square plus AM square. Okay, means hypotenuse square is equals to perpendicular square plus base square. Okay, so OA is what? It is hypotenuse. OM is what? OM is perpendicular and AM is, yes, base. So we can write by Pythagoras theorem. Okay, so now here is OM is 17, means 17 square is equals to OM is 8, means 8 square plus AM square. We have to find the value of AM. So here we get AM square is equals to, okay, means 17 square means 289 minus 8 square means 64. Okay, so after solving this we get 225. Okay, so from this we can find AM is equals to under root 225. So AM is what? AM, okay, AM is equals to 15 centimeter. Now we have AM is 15 centimeter. Okay, yes, so now we have AM is what? AM is 15 centimeter. Okay, and we know that by the theorem, here is, by the perpendicular theorem, here is OM is perpendicular to AB. So okay, so we can say that OM is bisect AB. OM is what? OM is bisect AB. We can write by theorem 10.3. Okay, it means we can write it as AM is equals to MB. Okay, and we have to find AB. So AB is what? AB is AM plus MB. Okay, so we can write AM plus AM. So this is equals to twice of AM, which is equals to 2 into 15. So here we get AB is equals to, AB is what? Yes, 30 centimeter. AB is 30 centimeter. So this is a required result. So AB is what? AB is 30 centimeter. So with the help of theorem, we can easily solve these type of problems. Okay, yes, so now let's move on. Yes, so the next question is, AB is a chord of length 24 centimeter. So we have AB, okay, which is 24 centimeter. Okay, and of circle with center O, and radius is 13 centimeter, and radius we have OA, which is 13 centimeter. Now find the distance of the chord from the center, means We have to find the distance of OM. We have to find OM. Okay, I hope you get this point. Yes, now my dear friends, here is we have length of chord AB. This is 24 centimeter. Length of chord AB is what? 24 centimeter. Okay, and we know that, and radius we have radius OA, which is equals to 13 centimeter. Okay, okay, and OM bisect AB. OM bisect AB. This is by theorem. By theorem, yes. 10.3. Okay, so we can write here as AM is equals to half of AB. Okay, so this is equals to half of AB. We have AB is 24, so this will be 12 centimeter. So we have AM is what? 12 centimeter. Okay, yes, so in triangle AOM, this is perpendicular. Okay, so we know that by the Pythagoras theorem we can write it as AO square is equals to OM square plus AM square, because by Pythagoras theorem. Pythagoras theorem. Okay, so this is hypotenuse square is equals to perpendicular square base square. Okay, now AO is what? 13 square. This is equals to OM we have to find, plus AM is what? AM is 12 square. Okay, so OM square is equals to 13 square means 169 minus 12 square means 144. Okay, after solving this we get 25. So we get OM is equals to under root of 25. So this is equals to 5 centimeter. This is equals to what? 5 centimeter. So OM is 5 centimeter. So I hope my dear friends you understand these things. Okay, so this is the method to solve this problem. So with the help of theorem you can easily solve the problems. Okay, yeah, so now the next question here is 48 centimeter long chord of a circle is at a distance of 7 centimeter. Is at a distance of 7 centimeter from the center. Okay, here is you can see that we have a chord AB which is 48 centimeter long. Okay, and the distance of center, the distance between center and the chord is 7 centimeter, means this distance OM. Okay, now we have to find the radius of the circle. Now again, this is again very easy question. So we know that QM here is the center is, let's suppose this is Q. QM is perpendicular to AB. QM is perpendicular to AB and QM bisect AB. We can write by the theorem. Okay, so here is my dear friends, we can say that AM is equals to half of AB. It means half into AB is what? AB we have 48 centimeters, so this is 48, and after solving this we get 24 centimeters. So AM is what? 24 centimeters. Now in triangle AQM, here is AQ square is equals to AM square plus MQ square. Again by Pythagoras theorem. By Pythagoras theorem. Okay, yes, so we have to find the value of AQ. Okay, so this is same, AQ square is equals to AM is what? AM is 24 square plus MQ is what? 7 square. So here we get, so after solving this we get 576. plus 49. So this is equals to 625. 625. Okay. So AQ is equals to under root of 625. So this is equals to 25 centimeter. So my dear friends, AQ is equals to 25 centimeter, which is the radius of the circle. Which is what? Which is the radius of the circle. Okay. Yes. So now my dear friend, let's move on. So here is, so the next question is, a chord of a circle is 12 centimeter in length and its distance from the center is 8 centimeter. Okay, now let's suppose we have a circle like this. Okay, let's suppose we have a chord AB. We have a chord AB. Okay, and the distance from the center of the chord is 8 centimeter. Okay, what is 8 centimeter? Now find the length of the chord of the same circle. Find the length of the chord of the same circle which is at a distance of 6 centimeter. Okay, now again, now we have another chord like this. We have another chord. Okay, so the distance between the chord and this center is 6 centimeter. What is? Yes, 6 centimeter. Okay, now we have to find, let's suppose this is CD. Okay, this is center O. This is center O. I hope you understand these things, my dear friends. So first of all, our main object is to find the value of CD. So for finding the CD, we have to find the radius of the circle. We have to find the radius of the circle. We know that AB is what? AB is 12 centimeter. AB is 12 centimeter. Okay, so from this we can easily find OA. We can easily find radius. Now let's suppose this point is M. This point is point M. Okay, so here is, we can say that OM is perpendicular to AB. Okay, so OM bisect AB. With the help of theorem we can say that. Okay, so now here is in triangle OMA. Again we apply the Pythagoras theorem because these angles are what? 90 degrees. So this is what? This is right angle triangle. So we can write OA square is equals to OM square plus AM square. Okay, now here is AM is what? AM is, since here we can write AM is half of AB. So half into 12, this is equals to 6 centimeter. So AM is what? 6 centimeter. So my dear friends, we can apply this. So we have to find OA square is equals to, so OM is what? OM is 8 square plus AM is what? AM we have 6 centimeter. So this is 6 square. Okay, I hope you get this one. So now 8 square is what? 64 plus 6 square is 36. After solving this we get 100. Okay, so from this we can easily find OA, which is equals to under root 100. So this will be 10 centimeter. So we have OA is 10 centimeter. Now we have radius which is 10 centimeter. Now join CO and DO. Okay, so CO is what? CO is radius, and we know that radius is what? Radius is 10 centimeter. Okay, now let's suppose this point is N. This point is N. Okay, yes, so now my dear friends, here is, we can say ON is perpendicular to CD, because we know that if we draw a line from center to the chord, this will be always perpendicular. Okay, yes, so now here is ON is perpendicular to CD, so ON bisect CD. Got it? So from this we can say that CN is equals to ND. Now let's suppose this is equation number 1. Now in triangle O and C, means we are taking this triangle 1. Okay, in this triangle, again we know that this is right angle triangle, so we can apply the Pythagoras theorem. So we can write here as OC square which is hypotenuse, ON square which is perpendicular, plus CN square which is base. So this is what? This is by Pythagoras theorem. Okay, I hope you get this point. So now here is OC is what? OC is 10 square. This is equals to ON. ON is what? ON is 6 square. Okay, plus we have to find Cn, so this is Cn square. Okay, so Cn square is equals, so Cn square is 100 minus 6 square is 36. Okay, now here is, this will become, if you solve this we get, so this will be 64. Okay, now if you solve this, Cn is half of 64, so we get, yes, we get 8 centimeter. So Cn is what? 8 centimeter. Okay, now if Cn is 8 centimeter, then ND means this line, this is equals to 8 centimeter. Okay, and we have to find CD. So CD is what? Cn plus ND, which is equals to 8 plus 8. So my dear friends, we can say that CD is, so CD will become 16 centimeter. So the other chord is what? Other chord is 16 centimeter. So this is our answer. Okay, my dear friends, I hope you get this point. Yes, so now my dear friend, let's move on. Yes, so the next question is, diameter of a circle is 26 centimeter and the length of a chord of a circle is 24 centimeter. Okay, now find the distance of the chord from the center. So according to this question, let's suppose we have a circle like this. Okay, and we have diameter. Let's suppose this is center O. Okay, and we have, let's suppose this is diameter. This is A and B. Okay, which is equals to 26 centimeter. And the length of chord of the circle is 24 centimeter. Let's suppose we have a chord like this. This is CD, which is 24 centimeter. Okay, now find the distance of the chord from the center. Means we have to find, if we draw a line on CD from point O. Okay, so we have to find, let's suppose this point is M. This point is what? We are writing like this. This point is M. Okay, now my dear friends, here is, now join CO and OD. Now we know that diameter is what? Diameter is 26 centimeter. So the radius will be 13 centimeter. Okay, radius will be what? 13 centimeter. So here we can write as diameter is equals to 26 centimeter. So radius will be 26 divided by 2, we get 13 centimeter. Okay, and we can write it as, now here is OM is perpendicular to CD, so OM bisect CD. So we can say that MD, we can write MD is equals to half of CD. Okay, and half into CD is what? CD is 24 centimeter. So this will be 12 centimeter. So MD is what? 12 centimeter. Okay, now OD is, which is radius, so this is equals to 13 centimeter. Okay, yes, so now my dear friends, here is in triangle OMD. Okay, in triangle OMD means we are taking this triangle. Okay, in this triangle, here is, we know that this is what? This is a right angle triangle. We can write this is right angle triangle. Right angle triangle. So we can write, with the help of Pythagoras theorem, we can write OD square is equals to OM square plus MD square plus md square. Okay. Now OD is what? OD we have 13 square is equals to, okay, and here is OM is what? OM we have OM is, yes, OM we have to find this, plus MD is what? MD we know that, which is equals to 12 square. So my dear friends, OM square is equals to 169 minus 144. 169 minus 144. Okay. Yes. So here is OM square is equals to 25. So this will be OM is 5 centimeter. OM is what? 5 centimeter. Okay, so this is our answer. This is our answer of this question. Yes, so now my dear friends, this is enough for today. Okay, I hope you understand these things. So thank you very much for listening me. Okay, and we will meet in the next lecture with the next amazing topic. So take care and goodbye.